Hey, my name is Diabeticus, and I will be explaining the math to finding the pseudo-focus. Finding the pseudo-focus mathematically will mirror most of the example about the stadium, the lines of sight, and the cone that I mentioned in the last video. To start, let's draw a different curve, say x cubed, and what we need is to find the quote-unquote center of attention. Well, this time is different. We would now have a different spot for the point, which definitely isn't somewhere in the middle. So let's tackle this question directly like before. Let's try drawing the lines of sight, which are more appropriately called the normal lines of the function. As we draw more of these normal lines, we'll form a cone, or actually, two cones formed from the normal lines. Okay, so what we have formed from these normal lines entirely is called the normal map, which is like plotting points, but instead you're plotting normal lines. Now that I've broken down the language of the stadium example to some technical terms, let us now focus, still no pun intended, on the math of this pseudo-focus. But first off, since we now have two cones, it must mean there are two pseudo-foci, and finding the pseudo-foci, well, I'll spell it to you that they're not too easy to find. But let's clear our heads of that thought for now, because I'll do my best to explain the relationships and graphs needed for understanding the location of this mere point. Firstly, our starting move would be to find an equation that represents the normal line. And for starters, the equation of a line is y equals mx plus b. But for amateurs, the equation can also be y minus y1 equals m times x minus x1, where the ones are the positions of the line on the x and the y, and m is the slope or steepness of the line. So, to find the right equation of these normal lines, let's start off with just one. Let's take the line lying on 1, 1 for example. And take note, these normal lines always intersect along the function, so their positions x1 and y1 are plain simple to find, which are 1 and 1, of course. So we immediately know the positions. How about the slope? Well, the slope is the part where the calculus comes in. Sorry, non-calculus people. My infinitesimal apologies belong to you. So anyways, the slope of this normal line is related to the slope, or derivative, 1, 1, 1. And remember that our function is x cubed, so according to the power rule, the slope function for any x is 3x squared. So this is what I mean, non-calculus people. If I use this 3x squared by plugging the x value of 1, then we'll get 3. And what 3 means is that if we zoom very very close to 1, 1, we'll only see a line, no curve, just a line, where the slope of this line is 3. So keep in mind that 3 is the slope along the function on 1, 1, but not across, which is what this normal line is doing. Now remember that this normal line is perpendicular to the function. So if you know geometry, that for any slope the perpendicular is, put slash 1, flip, and slap a minus. In other words, it's the negative reciprocal, which means the slope of our normal line is 3 slash 1, flip, and slap a minus. Negative 1 over 3. There we go. And with this, we're now complete. As we forge the positions and the slope together, we now have y minus the y position, 1, equals the slope, negative 1/3, times x minus the x position, 1. That's the normal line at x equals 1. And if you weren't fast enough, let's do another example, x equals 2. So, obviously, the y when x equals 2 is 8. 2 cubed makes 8. So we have 2, 8, capiche? 2, 8 makes for our position, so now we just need a slope. Again, for the slope, we need John derivative for this, so we refer to 3x squared again, which is x cubed's derivative. and plug the x value to it. Evaluate, we get 12. To make sure it's 12, let's zoom and check that the line has slope 12. Okay, so 12 is the slope along 2, 8, not across. So we use the perpendicular identity. 12 slash 1, flip, and slap a minus. We get negative 1 over 12. And negative 1 over 12 is the slope of Mr. Normal Line living on 2, 8 Avenue. So together we have y minus the y position 8 equals the slope, negative 1/12 times x minus the x position 2. Alright, I guess it's now safe to move on to the next part. Let's generalize. So you have a normal line on x equals apple. This means our y value is apple cubed, making the point apple cubed. Now we have our positions. Let's find the slope. Again, refer to 3x squared, the slope of x cubed, and plug apple to x, giving 3 apple squared. Then do the perpendicular. Slash 1, awesome 180, and minus. We have negative 1 over 3 apple squared. Next, we mix things up and get y minus apple cubed equals negative 1 over 3 apple squared times x minus apple. Boom! We have a general equation, where if we set apple to 1 or 2, we are repeating the last two equations we made, but instead in the pace of like 10 seconds. Now that we have the general equation, we now possess the divine mathematical power to better understand how the normal map works, which is simply just a system of normal lines. And we can use this equation to find the location of intersection of two closed normal lines, which lies on the cone's surface. And this cone, my folks, gets us closer to the summit where the pseudo-focus lies, which we'll do in the next video. Okay, bye, see ya, next video.